Hi, welcome to part 2. Let's look at solving one-step equations. So to solve an equation, one key idea that we need to be able to do, or thing that we need to be able to do, is to get the variable all alone on one side of the equation. So our goal is to have something like this. Let's say our variable is x. X equals, and then you're going to have your solution, which should just be a number. Okay, so that is our goal. So we're going to start very simple with one-step equations. One-step equations will help us remember what opposite operations we can use. Okay, so to solve or to get the variable all alone, we must undo what is happening to the variable. Okay? And to undo them, we need to know what opposite operations would undo them. So let's look at this first case. We have x plus 3 is equal to negative 11. Here's x. We want to get it alone. So we have addition going on. Specifically, we're adding 3. So to undo adding 3, we need to subtract 3 from both sides. And anytime when we're working with an equation, we need to do the same thing to both sides. So the opposite of addition is subtraction. All right, so we're going to subtract 3 from both sides. Minus 3, minus 3. And it's a very good habit to actually write that, especially if you're supposed to be showing your work. So these actually cancel because 3 minus 3 is 0. That was undoing it. So all I'm left with is x, bring down the equal sign, negative 14. Always be aware of your equal sign. Sometimes if you lose the equal sign, things can get really confusing. All right, let's check our answer to make sure it's actually correct. So I'm going to plug it back in right here and see if it actually works. Does it? Does negative 14 plus 3 equal negative 11? Yes, it does. Okay, so here we're doing the second one. We have subtraction happening. Specifically, it's subtracting 5. So the opposite of subtraction is addition. So we are going to add 5 to both sides. To both sides. It's always to both sides. Okay, plus 5, plus 5. This cancels and we just have x equals 17. Let's check. 17, take away 5, does that equal 12? Yes, it does. All right, then we have multiplying. Here we have 3 times x. Even though we don't have a symbol here, this is multiplying. I can put a dot there if I want to. But anytime you see a number and a variable next to each other without any symbol in between, that's multiplying. So we're multiplying times 3. So the opposite of multiplying is dividing, or division. So we're going to divide by 3 to both sides. Now notice I'm not going to use this. Okay, we use a fraction bar in algebra. Okay, so we're going to go divide by 3, divide by 3. 3 divided by 3 is 1. And the reason this cancels is because we're multiplying something by 1. Multiplying by 1 doesn't do anything. So 1 times x is just x. And then over the other side we have negative 7. Let's check our answer. So plugging in the negative 7, we're multiplying 3 times negative 7 to get negative 21, and it works. All right, last but not least, we have division. This is dividing by 5. Okay, and remember we're not going to really see this symbol much anymore, or at all. Instead, you're going to see this. So we're dividing by 5. So the opposite of division is multiplication. So we are going to multiply both sides. So times both sides by 5 to both sides. Now here's how I actually write it. I use parentheses and I put the 5 on the outside. So the 5's cancel, just like the 3's cancel in the problem above, and we get x equals 50. Now, if you looked at this problem originally and you thought the answer was 2, that's a very common mistake because you're thinking about 10 and 5 and dividing, but we need to think what divided by 5 gave us 10, and the answer is 50. 50 divided by 5 is 10.